on YouTube.
Good.
Yeah, you're good.
All right, awesome. So hello everyone, and thank you for joining us today. This is our first episode of our Elementary Live Learning at Home session, 2021 summer session, on the topic of engineering and sports. So in this episode, we are going to talk about buoyancy and kayaking and how engineers build the best sports equipment for sports athletes so that they can win. We are now live on both Zoom and our Engineering Outreach YouTube channel. My name is Maham. I am your Engineering Outreach Program Instructor, and I'm going into grade 12.
Hi, my name is Nicole. I'm also going to be your engineering outreach program instructor, and I just finished.
Awesome. Just a quick reminder, all of you are muted. Want to make sure everybody is rid of all the background noise possible in our call. So we just ask that you guys respect our rules here of having your microphones and cameras muted the entire time. The reason for the camera today is just because we are live on Zoom, so you guys, just for safety and privacy purposes. Ensure that you have your first and last name on if you can. The chat function should only be used to talk about the activity during the session, so if you want to answer questions or ask questions, that's good. And just, make sure you please respect everybody, no matter what, because this is like a learning curve for everybody. We're learning online, so everybody learns at different paces, and we would love for you guys to respect that. For individuals watching our live at home learning session on YouTube, our sessions are being hosted live on Zoom. If you would like to participate, if you would like to participate and interact with us, you can still register in our engineering webpage as seen on the screen below. So below on the screen, you can see a little link here. If you want to screenshot the page, you are good to do so. I think we've gone over all the rules, so I think we are good to move on. And just a quick FYI, we are recording this on our YouTube channel, but consent was already filled out in the registration process. All right, so we are talking today about STEM. Let's see, so STEM stands for, because it's our first session for a new season, I'll go over it first. So STEM stands for science, technology, engineering, and math. Science is understanding the world around us through experiments. I kind of like to think of it as trying to understand all the invisible things between all the things that we can see. So for example, we can see that, everything falls down, but why is it? We called it gravity. What does gravity do? Gravity is invisible, and that's what we try to figure out. We have T for technology. So technology is anything that helps us achieve a goal, the tools and machines that help us solve problems. Technology is basically another word for tool, but remember, it doesn't have to be electrical like it sounds. So a water bottle is technology, but also is technology. The E stands for engineering, which is solving real-world issues by designing and building models. And we have the M for math, which is using numbers, shapes, and patterns to understand the world. Math is super duper important, people. All right, so let's take a look at one type of engineering. My question for you guys here, answer in the chat, is what is manufacturing engineering? Anyone ever heard? Oh, I actually put it. What is manufacturing engineering? Any guesses? I see Nathan and Jason are helping us here understand buoyancy and what that means. Manufacturing engineering, any ideas, any thoughts what that sounds like? Manufacture, engineer. Have you guys heard of the word manufacture before? Right? This is gonna go to the manufacturer. That's where they built all of stuff. So let's take a closer look. Manufacturing engineers design, develop, and test systems that find the right amount of human and natural resources, technology, information, and cost to implement the best process to manufacture their product or service. No? So manufacturing engineers do all the designing, developing, and testing of systems, just like engineers, and they try to use the best resources and most effectively as possible. And their goal is that all this stuff should help to create the best process to manufacture their product or service. Remember, manufacture basically is the same way of saying create, but it's more, it's just like a really technical way of saying it. Let's take a look. Yeah, so we have here the definition: manufacture equals making things at a very large scale. Yes, very, very true. Yeah, I have a question for you guys. Do you guys know of any other types of engineers? You guys ever heard of any other types of engineering? Anybody? Let's take a look in the chat. If you have some answers, I see one answer. Biomedical, software, mechanical, etc. Yeah, it's lots of engineers. Who do you guys think would work with a manufacturing engineer?
Builders.
Builders? Is that what I heard? Yeah, that's a good one. Very, very true. Another kind of engineering that would probably work with a manufacturing engineering is chemical engineer, or an engineer that does a lot of work with metal. And also, for example, if there's a chemical product that they're trying to create a lot of, chemical engineer is going to work on the product. Manufacturing engineering the manufacturer engineering is going to work on the machine line and making sure all the material and the machines that make the chemical work. So they both have to work together. And I got lots of responses from one friend here about other engineerings. I have Nathan and Jason say civil. Oh, that was Jason. And biomedical, software and chemistry, chemical. Yep, that's good. Awesome. Let's take a look at another one here. Sports engineering. Anyone ever heard of sports engineering before? No, I see Jaden's like, I've never heard of that. Awesome. So this is a very unique and niche type of engineering that tries to apply engineering principles to solve problems in sports. So we consider how athletes interact with their equipment and their environment. So sports engineers try to work with, well, let's see how much training progress you're making. They might use their engineering skills to figure out what kind of tools and equipment would work best to train them. So here are all the other disciplines that are kind of part of that sports engineering field and that could also do the same stuff. So mechanical, material science engineers, biomedical, we would have manufacturing engineers like we just talked about, computer, as well as civil. So for example, if we were trying to figure out best design for sports equipment, building sports facilities, if we're trying to analyze athlete performance, develop performance and safety standards, develop coaching and training tools, these are all things that sports engineers would generally be concerned with. And they're usually concerned with external factors, so on how an athlete interacts with the equipment or their environment. Mechanical engineers understand the physics and motions behind a sport, and they use the sports equipment to optimize the design of this kind of equipment. Now, have you guys ever heard of material science engineer? That one's a little bit more unheard of, I think. Yep, I got a bunch of yeses from folks once, yeah. So material science engineers like to consider how the material that they're going to use is going to perform and affect the athlete. So for example, this one's a little bit, maybe not something that they would work with, but kind of in the same zone. A lot of designers at Nike, for example, when they're trying to figure out the next best shoe to sell and how to make it the most effective for their sports players. As an example of where materials engineers could also come into play if they wanted to, because it's dealing with materials that the athlete is going to work with. You guys heard of biomedical engineering before? Like creating jerseys or cleats. Yeah, that's exactly right, Nathan and Jason. For biomedical engineer, I see someone has right Pfizer. Yes, like vaccines. So biomedical engineers definitely work with vaccines. They are able to understand the capabilities and limitations of humans when performing the motions of sports in this case, and being able to either enhance or accommodate these factors. We have civil engineers, and they try to understand the structural needs of the environment that athlete needs to perform their sports. For example, who do you guys think makes the stadium in which Olympics happens? Or who makes the stadium for all the different sports that are played? And the hockey rinks and ice skating rings. So yeah, civil engineers to some level are also involved in that. Computer engineers will develop models to determine the best training and workouts to optimize the performance of an athlete. So timekeeping equipment for photo finishes in swimming and tracking everything to the millionth of a second. And finally, we just talked about manufacturing engineers, and they are able to manufacture sports equipment at an optimized rate. Awesome. So we just learned a lot about the different engineers that are involved in sports engineering. So you could go straight into sports engineering, or you could take one of these broader paths and also apply it to sports. Now, I'm just going to quickly mention our activity here so you guys can recall it later on. We're going to become manufacturing engineers, and we're going to design the best kayaking boats. Keep that in mind. All right, my question for you today is, why are some animals able to float in the ocean? Why are some animals able to float in the ocean? If you take a look at a duck floats above a pond, above the sea, but can a chicken do the same thing? Some animals are definitely better at floating than others, right? We can all agree about that. Some animals have gills, yeah. Buoyancy, maybe that's something important. Yeah, we're guessing. Okay, cool. And why do some objects, such as sailboats, float partially in the surface? Like they're there, they're a little under, and they're a little over. How does that work? Oh, any ideas? Okay. Well, we've kind of come to our experiment for today. So oh, thank you. So here's the idea, folks. We are going to do a experiment. Oh, I see Nathan and Jason says the size and the shape of the object, and Joshua says because they are light. Okay, yeah, good answers to those questions. I like it. So we're gonna move on to our experiment here. So I am gonna do what it says on the screen. I'm gonna have an egg. Okay, and water and salt. So here's the thing, guys. What do you guys think is going to happen in experiment number 1? An egg goes into a glass with water. What do you think is going to happen? I want your hypotheses in the chat. You don't have an egg. You're not supposed to do the experiment. That's why. I'm going to do it, and I'm going to show you how I do it. So I have my glass here. I think you can see it pretty well. And this is my water bottle. It has my water.
I think it will sink because it is very heavy and it might have yolk in it.
I like your thinking. So you also gave me a reason. You think it's going to sink because it is heavy. Okay, excellent.
And the water is, you're putting the egg in a glass with water, not like a big ocean. It would just stay on the ocean because the ocean is more water than in a glass.
Oh, that's true. That's a good point. We're just looking at like a small amount. I see someone's hands up. I see iPad has your hand up. It's going to, sorry, can you say that a little bit louder?
It's going to float.
You think it's going to float? Okay. I like it. We have two opposing hypotheses here. Two of our manufacturing engineers have said opposite things. Some people in the chat are saying it's going to sink. Sink in the sink. By the way, yes, a hypothesis is like an educated guess based off of information you already know. So my camera's on, right? So let me point this again to our experiment and let's continue to see what happens. Okay. So y'all just have to take a look. So I've already filled this with water, as you saw me do. I'm just gonna put the egg in. I'm kind of scared. I don't want to mess. Okay, so it's in. I release the spoon. Oh, can you look at that? Can you guys see it? It's like white on white. So, folks, it looks like this egg is not going to float. It just sank to the bottom. Interesting. Okay, let's take a look at experiment number 2. It says we're going to add salt to a glass with water and then add an egg. Okay, we're going to add an ingredient. We're going to add salt into our experiment. That's really interesting. I'm just patting it over here, patting it dry. So here I have some table salt. What do you guys think is going to happen this time? Any new ideas? Is it going to explode or something? I don't know. It's making me hungry. Oh, okay. We have Nathan and Janella saying that it will float. And Jaden's saying, are we starting now? So Jaden, we're just working on an experiment right now. It's part of our presentation.
Okay.
Yep. We're going to be making kayaks, remember? So that is our other part. So I have a spoon here. I'm just gonna, that's a lot of salt. But in the name of science, we're gonna put it in here.
Well, the salt will make it float because it's gonna make the water stronger.
Oh, okay. I like that you chose the word stronger.
Instead of like the water by itself, it's like you could drown in water, but like you could also float if you like make yourself. So like salt is making it float and making the water stronger in a way.
Okay, so like it's like the water molecules and the salt molecules are like working together, so now it's stronger, kind of like that. Okay, folks, so I put about like 2 plastic tablespoons worth of salt in here. I see Ima's hand up.
Do we have to do that like right now?
Nope, don't worry about this. This is just like a live experiment. We're gonna do our other activity later on. Just watch for now. Yeah.
Okay.
Thank you. All right, moment of truth, people. I'm gonna put the egg inside my glass. People said it's going to float. I hope I put enough salt. Let's see, so it goes in, and oh, wow. It also sinks to the bottom of our glass here. Do you guys think I should change something about our experiment?
Yeah, because you maybe because you didn't put that much water. Like
I think the amount
of water, like if you put a lot of water, then it's gonna float. Because like you put it, like if you use the same amount of when it was like not floating, then it might do the same again.
I've added more water, but I don't think that the quantity of water matters as much versus what's actually in the water. Okay, I'm gonna try this experiment one more time, and maybe we can make some changes as we go along in our presentation if something different doesn't happen. So just mixing. It's so cloudy in there, people. Like it almost, yeah, this is pretty undrinkable. You guys want to know a quick hack though? If you ever have hiccups, salty water is the way to go.
Yeah, I had to do that, and it was not pleasant either.
Yeah, it doesn't really taste that great. Okay, we're gonna try this quickly. We are gonna.
My throat is easily clogged.
Ah, I
I
see.
could potentially die if I was in the water for like 10 minutes.
I see. Okay, it looks like. You guys see it? I don't even want to touch it because I don't want it to. I think it worked, people. Okay, let's angle it.
Told you.
Ta-da! Can you guys see that?
Yeah.
The white egg over the slightly white water over the slightly white table. Okay, so it looks like this experiment was a success and some of your hypotheses were correct. When we have our salt and our water in the same container, and then we added our egg, it looks like it floated. So that's pretty epic. We're going to put our experiment to the side here. Let me dry it off a little. But Ema, is your hand still up? I can see your raised hand button is still on.
I forgot to put it down.
Oh, yeah, no problem. Yeah, it's really true. Part of doing the experiment is testing and repeating tests to make sure it works to confirm things. Awesome. So let's take a look at our next stuff here. So we're talking, you know what was really cool about what our friend here said? He said the water would become stronger. And I think a more scientific and accurate way of saying that is that it'll become more dense. Has anyone ever heard of the word density before? I'm sure you've come across it. Density.
Yeah, I was thinking of saying that, but
Yeah, you
then I forgot it. That's the thing. I
Yep.
forgot it. I don't remember those kind of things.
Yeah, that's okay. No worries. So density compares the amount of matter of an object to how much volume it has. Density is the same thing as taking the mass and dividing it by its volume. So I want you to take a look at this picture over here. There's a bunch of different liquids in the same glass, and they're all different colors. But along with that, there are also different levels of density. We have honey, and it's, as we know, super thick, super sticky, so it goes straight to the bottom, but it's so strong, it's dense enough to hold the next liquid on top, which is corn syrup. And you can almost see like a clean line between corn syrup and honey and maple syrup and milk, right? They're not going into each other's liquids. They're just staying in their own sections. So this is showing you how they have the same volume, they're taking up the same space, but they have different masses. Honey is thicker, heavier than some of the other liquids here. So it's actually so strong, it's floating them up. Let's talk about these objects over here. Well, actually, first let's talk about these objects over here. Where is my pointer feature? Here it is. So let's talk about our ping pong ball. This is a dice over here and a cherry tomato. And our bolt. So we can see the bolt clearly. And we see the ping pong. What is the biggest difference between ping pong and a bolt? You wanted to know which one was which without even opening your eyes. If I just put the two objects in your hands, how would you know which one is which? Heavier, someone says heavier. And the shape, true. I see, Propty, you have your hand raised, go for it.
Because if you put it in water, the bolt would probably sink and the ping pong ball would probably float.
Good observation. And if I wasn't looking at them, if I just held them, I can tell that one is slightly more heavy or dense than the other. One has more air in it, and one has more of its own material in its self, basically. So if we take a look at rock and bread, which object will likely float in water? People, what do you guys think? Which object will likely float in water? Bread or the rock? I have answers, probably saying bread.
No,
Some people saying, I don't know. Interesting. No
it's the
problem.
bread.
Right, so, oh my gosh. Yeah, so when we look into the ocean, you're gonna notice that, yeah, you don't really see any rocks floating around. That's definitely going to sink. And the bread is a little bit less dense, or yeah, it's a little bit lighter. So it's going to float. Let's take a look at our next slide. It's talking about buoyancy. You guys heard of the word buoyancy before? I know you guys were talking about it in the chat, so definitely think so. Buoyancy basically, so boy, the word boy in this word means to float in Latin. And buoyancy and everything about buoyancy, such as like it as a characteristic, was discovered by Archimedes, who is a Greek mathematician, a physicist, and an inventor. And he discovered it with a golden crown. Basically, there was a king, and he was like, Mr. blacksmith, goldsmith person, I'm going to give you some gold and you're going to make my crown. But then when the king got the crown back, he was worried that all of his gold isn't actually in the crown. He thinks that some of the gold is stolen, that the goldsmith actually took some of the gold. But he didn't know how to figure out if this was the exact same amount of gold. So then he gave it to our friend Archimedes. And Archimedes was thinking, and he was like, I'm a scientist. This is totally my job to figure out if this is pure gold or not. So, he's taking a bath and he somehow drops the crown in the bathtub. And he realizes that because of the way it's reacting in water and how it's sort of floating, that basically because of its a little bit of sinking, the tub water is actually rising. So more water is moving up, water is being displaced. And he realized that this effect could be used to determine the volume of the crown. So he submerged the crown and it would displace the amount of water equal to its own volume. And by dividing the mass of the crown to the volume of the water displaced, the density of the crown could be obtained. And the density would be lower than that of gold if cheaper and less dense material has been used. So Archimedes then took to the streets, and he wasn't even wearing any clothes. And he was so excited by his discovery that he forgot to dress properly. And then he was saying, Eureka. Have you guys heard of the word Eureka before? This was kind of his expression to say that I have found it. And the test was conducted successfully, proving that that golden crown didn't actually have gold in it. It was mixed with silver. So this is a beautiful story that shows you how density and buoyancy were used. So buoyancy is a floating force, just like how an object is going to put its weight on water, like the egg was putting its weight on the water. Well, the water is also going to try to push back up slightly, in a way. But water is heavier than the boat, so the object here floats. Oops. Low density objects are more likely to float. So for example, inflatable balloons or those inflatable pool balloon thingies that you can chill in, and flutterboards and the swimming pool noodles. Those are all low density, and that's why they float really well. Buoyancy is the upward force of an object that is produced by a surrounding gas or liquid such as water. For an object to be buoyant or float, it must have less density than what it is floating in. So there has to have something attached to it that helps it float, right? So just like how we wear life jackets or a pool noodle, it's going to help us float because it by itself is less dense. When this happens, the water pushes you up and keeps you from falling in and sinking with a force called buoyancy. So the principle of buoyancy holds that the buoyant or lifting force of an object submerged in a fluid is equal to the weight of that fluid it has displaced. This is very technical words, but it's going to make a lot of sense in our diagram here. So this beautiful diagram is showing that we have an object. It's going into the water. And obviously this water is not going through it. It's actually going around it. It's moving. And gravity is pulling this object down. Meanwhile, this object and how dense it is going to determine how much of water it's going to move around. This definition here is telling you that buoyancy holds that the buoyant or lifting force of an object submerged in a fluid is equal or greater than to the weight of the fluid it has displaced or pushed away. Otherwise, the object will sink. And Josh was asking me, what was the scientist's name again? His name was Archimedes? Yep.
My grandma lived on Archimedes Street.
Oh, interesting. So I have a question for you guys. So, like really huge ships and like cruise ships, like they're made of metal and steel, and they're obviously heavier than water. Why is it that they're floating? And how come we can be sure that a submarine is going to go underwater? Let's take, I see Ima's hands up. Ima, go for it.
It's because I think it's because the shape of the boat has a good angle at the bottom for it to float, which is the shape of the other ones, which is like curved and flat at the bottom. So that's the shape that makes it float. And the submarine doesn't have that type of shape, which is a different one that allows it to sink but still moves underwater.
Okay, so you're thinking some of the physical aspects of the boat itself. Okay, that's a good point. Let's see. Let's take a look. So I think you're kind of right with that whole, the shape of the boat really matters. Let's take a look at some of the answers here. Because the weight of the boat is the same on the top and the bottom. It's because the air in the ship is less dense than water. Yeah, it's lots of those things. It's the fact that gravity is pulling it down, but the water is kind of also moving out of its way. It's displacing. Okay, so has anybody here ever been kayak? See two responses. One says no.
No, sorry.
All right, we have a couple no's. Okay. Nope. Oh, one person has. Awesome. And you've seen it. Okay. Excellent. So, yes. Kayaking. Okay, but I bet you guys have gone canoeing, right? Like they're very similar. So, kayaking is the use of a kayak and paddle boats or paddles to move across water. And it's different from canoeing because of the way they have to sit and position yourself in that physical boat. So that's the main difference between canoeing and kayaking. It's the way that you have to sit inside of it. So some of the many types of kayaking are whitewater kayaking, sea kayaking, touring, recreational kayaking, sit on top kayaking, kayak fishing, and kayak camping, to just name a couple. So each of these genres require different gear and have different skill requirements. Now, essentially, a kayak has, it's just a physical boat. It has paddles, and each type of kayak uses different kinds of paddles. And it has PFD, which stands for Personal Flotation Device. And this is essentially a life jacket in case of emergencies. It has spray skirts, which helps keep the water out of the kayak. And then there's a helmet. So for whitewater kayaking, there is a helmet. But some of the more recreational ones, I don't believe so. Here are the world records for kayaking. So for 200-meter race on male, it was 33.8 seconds. And then for 200 meters female, it was 37.898 seconds. So yeah, within seconds, like these people are super fast. All right, let's take a look at the points that Ima and some of our friends are talking about, which is the physical dimensions of our kayak. So you guys remember the words length, width, and height from school? Length, width, and height. Yeah,
Yes.
Nathan. Awesome. I heard a yes. I see Shakti says yes. Nathan Jason, Nathan Janella. They're both saying yeses. Awesome. So we're talking about the width right now, right? So when we're considering as manufacturing engineers to create our boat, we have to think about how wide it is. The more wider it is, the more stable it is. And if a person is really large or tall, then they're going to like this boat more because it's wider. It can spread out their weight, right? But if you have a narrow boat, it's going to be more efficient. It's going to cut through water faster and better. So wider boats, more stable. Narrow boats, they cut through water faster. They are more efficient. That's two things to consider when you're considering how wide to make your boat. Let me take a look here. Also, when we're talking about efficiency, we like to talk about how easily the kayak glides, right? So I'm saying cut through water, I mean how nicely it's going to move across water. Let's take a look at the length. So what happens when our boats are really long versus when they're not so long? A longer boat will track straighter, glide further, and travel faster, which makes it more efficient. So longer sounds like it's slightly better. The length also adds a stability and capacity. A shorter boat is easier to handle and can be more maneuverable. So maneuverable kind of means like to manage or turn a lot to manipulate. So it's maybe easier if you have to make a lot of turns to have a shorter boat. But a longer boat is going to be more efficient. It's going to like glide across better. It's going to be more stable, and it's going to carry more weight or even more people. So that's definitely to consider as manufacturing engineers when we create our own. Now let's talk about the depth. So we talked about, remember when I said length, width, and height? So in this case, we're talking about depth, which is basically the same thing as height. Just another way of saying it. So basically, from the top to the base of our boat, how much distance is that? Deeper boats are really good for larger and taller paddlers, and they have a higher capacity, or the higher amount of capacity, so they can carry more weight. But if you have a shallower boat, so it's not very deep, those are less affected by wind, and they're good for smaller paddlers. So little kids can easily manage those, and wind is not going to really disturb a shallow boat as much as it's going to disturb a deeper boat, which makes sense because obviously bigger. Let's take a look at the shape of these boats. All right, so this is going to show you, a diagram and then like a physical version of that almost. So this is called a hull. So the hull is like the inside part. And this is the shallow arch, which is really good for stability. On the other hand, we have our shallow V, which is easy to maintain direction because it has this little point here, right? So you can make sure you're using your weight properly to distribute across that little point and lean on one side or the other. Shallow V that I just talked about, their V shape improves tracking and has a lively feel and delivers very comfortable stability. We take a look at soft chine smooth edging over here. A smooth transition from the bottom of the hull to the sides. So soft chines give smooth edging and unlimited angles, and the majority of kayaks that we build have a soft chine. On the other hand, a hard chine kayak has a well-defined edge where the hull bottoms meet the sides. So this increases the initial stability, and hard chines give defined edging angles and assist in holding an edge. So let's talk about some of the other shapes of these boats. We have the sweet form and we have the fish form. This fish form sounds like, oh yeah, the shape of a fish, which means that the front side is slightly more wider than the back. And I feel like but on the sweet form, the back side is slightly more wider than the front. So you can tell they're not exactly symmetrical, right? Like if I cut a line down here, they are not the same shape. They're not the same length. This side is wider and it's becoming shorter quicker than this side. But on this side, it's the complete opposite. Our arrows are showing us that it's actually widest here, and then it's going to become smaller. And hydrodynamics. So have you guys heard of the word aerodynamics before? Anyone heard of the word aerodynamics? I got 4 answers, and they all saying yes. All right, smarty party. Well, I'm sure you haven't heard of hydrodynamics before. Basically the same thing. So hydro meaning water, dynamics meaning energy or physical force in motion and how it's affecting that. So if we put this together, we're basically looking at the effects of water when it's in motion. So if you ever noticed, so basically in hydrodynamics, we want to consider the same things as aerodynamics, but we also want to consider how water is going to push in onto that boat. So the motion of solid objects through fluids. We're concerned with the forces and the drag that is happening when water is acting on our boat. All right, so we're going to use the engineering design process. Remember I mentioned what our activity was for today? Can someone remind me what our activity is? You can remind me of our problem. Anyone remember? I see iPad raise his hand. iPad, go for it. Can we talk a little bit louder? I can't hear you.
The activity was to make a canoe that floats.
Yeah, we want to create a kayak that floats. Awesome. Love it. You guys are so correct. Okay, so what are some ideas? What materials could we use today to make our kayak? Yes, we're at the brainstorm ideas part. We're thinking about Yeah, so Prappy says paper. Nathan says styrofoam. I really like that. Tito, I see your hand up.
Maybe like cardboard.
Cardboard. Yeah, that's a
like
good one.
cardboard.
Really like cardboard, cardstock. Yeah, awesome. Stuff that floats on water. And we're going to design a solution, then we're going to make a model, and we're going to test and evaluate. So let's quickly go to those slides because we've already started the part here. So you mentioned cardboard, you mentioned paper, tinfoil. I think our main use today is going to be tinfoil. I have my tinfoil out. You guys can take yours out soon, right after we design something. What are you guys thinking? We're going to make our own kayaks. Using tape would be helpful if you have it. What about some of the shapes that we talked about? What shapes do you guys think is going to work best for your kayak? Construction paper, yeah, it's a good one. Anything that won't get like wet and soak, you know? What shapes are you guys thinking about? Are you thinking of making yours kind of maybe flat from the bottom or maybe arching it a little bit? What are you guys thinking? Personally, I like the fish form over here. I want to use the fish form method. I don't know why my pointer's not working. Yeah, fish form. Fish can cut through water more easily the way it looks. I agree. iPad said they're going to make a flat bottom. Prappy says they're going to go flat bottom. Awesome. That works. iPad wants fish form. Perfect. No one wants sweet form. Sweet form is pretty cool too, you know. Let's see. What else can we talk about? Does everybody have a sink or a large tub or basin that we can use? Probably sweet. Tito wants to use sweet. Perfect. A fish has less capacity. Yeah, very true. So we're going to be using aluminum foil because it's, you know, not going to soak and get wet as well. It's going to get wet, but it's not going to like absorb the water and go down like other materials. Are we thinking of a soft shine or a hard shine? Okay, so let's go to our design a solution stage. So I want y'all to grab your piece of paper and a pencil and let's make some designs here. I have a handy dandy notebook, bullet journal thing. I'm going to make one in here, but does everybody else have their paper and pencil out? You can basically draw what's drawn here, but figure out more or less what your dimensions are going to be. A fish can cut, so the shine should be soft. Okay, interesting observation, Nathan and Jason. And Tito says soft shine. Awesome. All right, so I'm going to start drawing mine. I want y'all to draw yours and let me know what you're thinking. I don't know if with aluminum foil I can create a seat, but let's see. Maybe I'm good at folding aluminum foil. I can create like a shape like this. Sort of like a fish form, but not gonna be really hard. And this is the wall itself. And then, so I think, yeah, this is probably going to be like the size of my palm. I'm just gonna write palm size. And I think it's also gonna be the width of my palm. Everybody else drawing? I'd like to know what's generating. Can I please put the materials in the chat? Yeah, so all you need is a paper pencil right now, and you need a roll of aluminum foil or tin foil. Yes, it's already in the chat with our handy friend here.
Excuse me, how do we make it? I don't understand.
How do we design our boat? Are you the designing part with me?
No, like what do we make it of and how do we make it?
Okay, so I'll show you that, but I just need you to design it first. So do you have a piece of paper and pencil with you?
Yeah.
Okay. And can you draw out the shape of your boat? So maybe talk about these things like.
So like draw the shape?
Yeah, exactly. Draw the shape of your boat.
Okay. So like I draw the shape and the design?
Yeah, like this was like somewhat my example. So I'm trying to figure out what kind of oval I'm making. Can you do that?
Okay.
Mm-hmm. And I'm trying to figure out the size. So if you have a ruler, you can maybe rule out what you want. I'm thinking,
So is it like a little one?
yeah, I'm thinking it's like one I can fit in my palm. So my palm's not super huge, but like it's a good size, you know?
Okay.
Yeah. It's about like maybe like 7 centimeters at most. Maybe I'm underestimating centimeters. Okay. What are some other ideas? Nathan and Jason, Nathan and Janelle. What do you guys, Tito, what are you guys thinking? Are you guys drawing your stuff out? Drawing your boat dimensions out?
Wait, do we need like the pretend paddles or just this?
Yeah, we could go ahead and make the paddles, but at this part, I'm just going to stick to the boat itself.
Okay.
Yeah, we'll make the paddles after. If you want to make the paddles now, that works too. I don't know. I feel like spoon would be a good paddle. But that's not aluminum foil, so maybe something lighter. I got a yes from Nathan and Janelle. So I'm thinking that they are making their thing. Popsicle sticks. Ooh. That's going to make it stronger. Yeah, that's really cool. So yeah, we've all, I hope, started working on our design. I'll just leave this on my design. I don't know if you can see it very well. So I'm just kind of writing out like how long it is, the size of my palm, how wide it is. I think also might be the size of my palm, and just kind of like overall shape. So I like the fish form. I tried to make it as oval as possible. When I build it, I don't really know what's gonna happen, so we gotta work on that. It's a quick design. I'll give you guys 2 more minutes to figure out your designs, and then we'll start building. Well, actually, while you guys are designing, I might show you some examples and get some inspiration. So, talk about the hard and soft shine that's kind of seen in the bottom of these boats a little, and they have points. So I think that's one of the hull shapes that they were talking about. Now, as you guys are creating your designs, I'm just going to play this video to kind of show you some ideas of how you can build yours. All right, first it was music. So they're just cutting out a square, and they're going to make the boat into a hull, and they're going to make the rim the same height all across. So this is like the rectangular one. And they're putting tape on if needed. Calculate the volume of the hull. So we don't have to really calculate the volume. We don't want to, but you definitely could. Figuring out all the measurements, the size, the length, the width, and the depth, basically, that we talked about. And the video just go. Okay. And now they're filling in with some sort of weight. So if you guys want to test yours with coins, you can, or rice, or how many markers you can fit if it's long enough. And now they're going to put it in a bucket that is deep enough to see if it's actually sinking. So make sure you spread out the pennies or whatever the weight is. And eventually it's going to sink, but let's see how many pennies they were able to get. 86 pennies. That's a lot. And then they're going to figure out some of the mathematical stuff like the mass and things like that. So it is 50:51. Are you guys ready to start building? confirmation here, folks. Are you ready to build? Design. I'll just place it here so I know what I'm making. Okay, so if you guys want to grab a sheet of tin foil, you can do so. So they said to cut out a square. If you have scissors, you can cut out a nice neat square. It's not like a way to cut this. I'm gonna grab my scissors, and I have like this much open because I want a lot of space to hold this. You guys think if I use a lot of crinkly and if I crunch my aluminum foil more, do you think that'll help my boat move and glide and float? Do you think having crinkly aluminum foil will work better? Nathan and Jason like the experiment. That's cool. I am gonna grab scissors and I'm just gonna cut right along here. I hack here, but this helps your scissors become really sharp. Okay, so definitely not the straightest cut, but that's okay. We don't really need it super, super straight. We just need it to be enough aluminum foil for today's activity. All right, so what from I could see to create the walls, let's go back a couple steps. You basically fold the sides in to make them equal heights. I see someone has their hand up. Go for it.
Can you make the kayak that we do
Wait, can you repeat that a little bit louder? Your voice is slightly muffled.
Can you make the kayak that we do?
So you drew out your kayak? Is that what you're telling me?
Yeah, can I make that the kayak?
Yeah, so if you're done drawing, we're gonna now make that kayak that you drew. So you don't have to follow exactly what I'm doing because I'm just trying to like figure out how I can make it look like my kayak. My kayak was like fish shaped. So I'm gonna use my scissors to like draw it out, but I'm not cutting on it. You can also use a pencil and lightly go over it to make the shape. I see Jaden's hands up. What's up, Jaden?
Yeah, so I drew on my kayak, but it's a little bit small.
A little bit small. That's totally okay. Because we haven't really built it yet, so you can do that.
Okay.
I have a rectangular sheet here, and I'm going to fold a corner in. Let's see what that would do. So I'm just folding a corner in. Kind of make an edge here. And I have this. So I just folded a corner of my kayak in. Again, you don't have to follow what I'm doing. You can kind of just do what you want to do. And now I'm folding the other kayak in. And now I have a point. So I have a point on my kayak. Like so. Now I want to kind of rise. Neatly fold things in more. So now I'm going to fold in the walls. So I just took one side. And I'm going to bring it inwards to the center of my kayak. And since I didn't cut this super straight, it might not be that straight. All right. Everyone following so far? Any questions? I've just made 3 folds. These look like canoes. Yeah, they could look like canoes. But again, the only difference is how people are seated in them. So they are pretty close. All right, I'm going to redirect this camera back. So again, I'll just repeat what I did. I cut out a rectangle, and then I took one corner and I folded it in. And then I took the other corner and I folded it in. So I have a nice point here, right? Pointy, pointy, pointy. Okay. And I'm going to one side, and I'm going to fold that rectangular thing in. So I have a folded edge here, a nice clean folded edge. Do the same thing on the other side. And I'm just going to bring that in. Now I have two rectangular folded flaps plus my pointy corner. And now I just have to make the wall stamps basically. Well, right after I point this in. So I like that it's like kind of pointy at the back here. So I can create a point by taking these two rectangular, these parts of the rectangle and just fold them in. If you want, you can tape along as we go. All right, so I'm going to lift one of these up and try to kind of crunch down the material. I'm trying to lift my wall up, and this kind of flaps are forming. So I'm trying to stick those flaps out and then fold them in. I take out this corner. I'm gonna push down a little, create a tip. Bring my walls up, just fold them in, like with this motion. Okay, so this canoe is, it's getting there. So I'm trying to fold in any of the things that are sticking out. This is a very narrow canoe, or kayak. I must point that out. And I'm gonna push this out. All right, and I'm just gonna go over and nicely fold any of the edges and things like that on the boat. All right, this is what my boat looks like. I'm definitely gonna go through now and tape some parts so that it actually like holds its shape. But what are some canoes that kayaks, I keep calling them canoes, that you guys have come up with? Is everybody started working on theirs and following okay? Let's see. Oh, Nishi says I'm done. Wow, that was fast. Does anyone need help building their kayaks? That's a very good question that I want to ask you too. Does anybody else need any help? So I take my tape and I'm just going to fold over these flaps that I created just so the shape remains. Some of you guys started mentioning that you're going to use popsicle sticks. You can put them on your face or when you're making the shape of your boat. Anybody need help? Nathan and Jason look like they're in good hands. Anybody want more guidance on how to make the shape of their boat come out? Pardon me?
I need help with my boat.
You help with your boat. Okay, did you cut out a rectangular piece?
Yeah.
Okay. And you know how they kind of made a rectangle inside their aluminum foil? Can you make a shape out in your aluminum foil? Like just make creases and make a shape. So you can make like a rectangle or an oval shape. Just like line it, just to draw it. Just so you have like a guideline. Okay. And then you can just bring in the sides and the flaps up and fold them over. All right, so I'm just going through taking my own. I don't really have a lot of faith in my sides, but I think the shape and the concept of it is really interesting. I think it's time to test this out. So I'm going to take this now over to my testing station, which is a bucket of water. If you have a sink or bathtub that you don't mind filling up, you can go there. I'm going to try to move my camera over, my entire laptop over. So let's go. So this is my final product. Looks like this. But theirs is more rectangular, so you can make something like that as well. Okay. So let's see. I really don't want this to fall into the. Okay. So give me 1 second to position my. Place this on top. And you guys see my little bucket here? You can't really see the water. Right, bucket, water, jiggling stuff. And I'm just gonna place the boat inside. So it's definitely floating. And now we just have to test how long it's gonna float for. I don't have lots of coins around, but I do have lots of erasers and markers. You can use anything you want to test out how well your boat floats. What I'm going to use is markers because I have 5 of those. So yeah, I'm going to use markers. I'm just going to place them inside my boat. So here goes marker 1. Still floating, pretty good. Marker 2, still floating, pretty good. Marker 3. Also, these markers are kind of the size of my ship, so that's also important. Marker 4. Marker 5. I'm actually surprised that this holds even 5 markers. So, basically, your test will continue until your ship sinks. But for us, because we are short on time, I'm going to start working on our reflection and talk about how this experiment went for you guys. So, is everybody testing their boat right now? I see 8 comments. Yeah, someone's asking here. Yeah, you can share your products at the end, just so we can get through. Okay, so you cut out your rectangle and you bring you kind of make a design on the aluminum foil, and then you bring it up. You like fold the walls up. Did anyone else test their boat so far? Oh, okay, I see. Proppy says yeah, Anuj, Proppy, Anuj. Okay, same people saying yes. So same 2 people. We have a couple folks who have tested it out. Awesome. So how much did your boat? Okay, first of all, did your boat float without anything on it? Did it float at all? Did your boat float? Okay, so yes, it did. Mine floated. Nathan and Janelle's floated. And Anuja's floated. Okay, so far, you passed the float test. Excellent. So, ching, that worked. Let's talk about how many coins your boat could carry before it sank. Now, I know some of you guys are probably still in that testing phase because I only had 5 markers. Okay, some people's didn't float. Jaden, it did not float.
Excuse me.
Yeah?
Can I go to the washroom?
Yeah, go for it. If it did not float, then you can probably pick it up, dry it a little, and try to recreate some of the edges. Maybe flatten it out more. Remember, the wider the boat, the more stable it is, so that could help. All right, if you're not finished your boat, no worries. You can just finish it now, test afterwards. For those of you who are thinking about paddles and things like that, what can you do? What can you add to your boat to actually make your boat move? Any ideas? What can we do to make our boat move? I have 2 answers here. Oh, okay, so some of you guys got 12 pennies, some of you guys got 28 coins. Yeah, so Mishi says I can use a fan, so you can use like wind power. That's a really interesting point. Just make sure your electrical devices are away from your water. Yeah, so some people used pebbles, paddles, 120. I'm assuming those are 120 coins. Must have been a really big boat.
120. Yeah, I didn't mean to put 1,020. I meant to put 120.
Yeah, but 120 is a lot of coins. I'd love to see your design or your project at the end. That's really cool.
Okay.
Anuj says that we can use paddles to make our thing move forward. There are 2 hands raised. Prapti, go for it.
I got 28 coins into my boat.
28 coins, awesome. You guys can like make this a competition with your family if you want, see how many coins we can get. iPad, I see your hand up. Oh, I also see your heart emoji. Awesome.
I forgot to put my hand down.
Yeah, no problem. That happens. Awesome. So we've talked about what worked, if it didn't float, how many coins it could carry. So ching, if you're still creating it, no problem. Changes. So we talked about, someone mentioned used a fan and wind power. We can use paddles. I can use a spoon to create a paddle, but like how would it move, like with some rubber band power. But we have come to the conclusion of our presentation, and our time is definitely up. So thank you so much for joining us in our live learning at home sessions and interacting with me and Nicole. If you guys want to join another program and you haven't already, you can use the link down here. But other than that, we are done for today. Any questions, comments? Now would be the moment to take those. Hi, Nathan and Jason. Thank you.